All right, today we're diving into something really mind-bending. What happens when physical reality itself just stops? We're going to the very edge of what we know, to a place where all the rules we thought were solid seem to completely fall apart. We all walk around with this sort of common sense picture of reality in our heads, right? But what happens when you push that picture to its absolute breaking point extreme? Well, it turns out modern physics has found exactly that place, and it's a doozy. So, here's our roadmap for this journey. First, we're going to face the paradox head on, right at the edge of reality. Then, we'll bring in this brilliant, almost humble idea from Niels Bohr that might just solve everything. From there, we'll see how it completely redefines what a physical question even is, stack it up against the multiverse idea, and wrap up with a really important thought on what it means to be honest in science. Okay, let's get right into it. Section 1, Reality at the Edge. And we're going straight to the ultimate stress test for physics, the black hole paradox. Okay, so picture this, because this is where things get weird. Let's say you're watching a spaceship fall into a black hole from a safe distance. What you'd see is the ship getting closer, slowing down, and then just freezing. It would look like it's stuck on the edge forever. But for the astronaut inside that ship, nothing. They'd feel totally fine, sailing right across that edge, the event horizon, without even noticing it was there. So this puts us in an impossible situation. Which story is true? Is the spaceship a frozen image on the edge of a black hole, or did it sail on through? Physics tells us both are correct. But how can that be? Our brains just scream, no way! Well, the key to unlocking this puzzle might just come from the legendary physicist Niels Bohr. He had this surprisingly simple, almost humble idea about what physics is even for. It's not about what reality is, he said, but about what we can know. This idea has a name, the epistemic view. And I know, it sounds a little philosophical, but stick with me because its physical implications are massive. It basically argues that physics isn't a quest to describe some hidden, objective world out there. No, physics is the science of what we can actually measure and say about nature based on how we interact with it. This quote just nails it. It's Bohr's whole perspective in a nutshell. It's this disciplined, stubborn refusal to guess about things that are fundamentally impossible to observe. The big takeaway is that in this view, our knowledge of reality is actually a part of reality itself. You can't separate them. Okay, so with that idea in our back pocket, let's go back to our black hole problem. This is where we get to something incredible called cosmic scale complementarity. Basically, the universe holding two truths at once. So, from this epistemic point of view, the story of the outside observer and the infalling astronaut, they're not a contradiction at all. They are both 100% valid, real descriptions. They're just context-dependent. Each observer can only measure things from their own perspective, so that is their reality. There's no need to pick just one. You've probably heard about this with quantum mechanics, right? How light can be both a wave and a particle depending on how you measure it. Well, this is that same idea, but blown up to the scale of the entire cosmos. It means reality is fundamentally tied to measurement. And it means there isn't one single objective universe out there, just waiting for us to look at it. And this leads us to an even more profound place, to a question that has haunted physicists for decades. We're talking about a boundary not of space, but of meaning itself. And the question is, what's inside a black hole? Let's just walk through the logic here, because it's really solid. Step 1. We know for a fact that nothing, no light, no signal, no information whatsoever can escape from inside the event horizon. Step 2. That means it is physically impossible, even in theory, for anyone on the outside to ever measure what's on the inside. So step 3, if we're following Bohr's rule, if you can't measure it, you can't talk about it in physics, then what's left to say? And here it is, the stunning conclusion. The question, what's inside a black hole, isn't a physics question anymore. From this point of view, the question itself is meaningless. It's physically undefined. It's not that we don't know the answer. It's that the question itself is dissolved into nonsense. I absolutely love this analogy. It just clicks, doesn't it? The event horizon isn't some door you could theoretically open. It's a boundary of meaning. Asking what's inside a black hole is exactly like standing at the North Pole and asking, so which way is north? The question itself has no answer because you've reached the very limit of the system you're using. Now, this whole epistemic view, it isn't the only game in town. There's another really popular idea out there for explaining all this quantum weirdness, and you've definitely heard of it, the multiverse, or the many worlds interpretation. So let's see how they stack up. This pretty much sums it up. The Bohrish view we've been talking about just accepts that there are limits to what we can know. It's a kind of disciplined minimalism. The many worlds view, on the other hand, does the exact opposite. It multiplies reality. It says that anything that could happen does happen, just in a parallel universe. You could call it bookkeeping maximalism. And here's the really interesting critique. While the multiverse sounds totally wild and radical, you could argue it's actually the more conservative idea. Why? Because instead of wrestling with these really tough questions about reality and observation, it just invents an infinite number of unseeable universes to make the math look clean. It's kind of an escape hatch. And that brings us to our final and maybe most important point, intellectual honesty. It's about seeing Bohr's idea not as giving up, but as a really powerful form of scientific integrity.
So why is it so honest? Well, for one, it draws a really clear line in the sand. It refuses to let pure speculation, metaphysics, dress itself up and pretend to be physics. It also bravely accepts that the act of measurement itself puts hard limits on what we can ever know. And you know what? It takes a lot of guts for a scientist to stand up and say, this question we keep asking, it actually has no physical meaning.
So I want to be super clear about this. This perspective isn't about giving up on finding reality, not at all. It's about being incredibly disciplined about what we are allowed to call physics. It's about demanding that our theories are tied to things we can, at least in principle, actually observe. And we're going to end on this profound idea. The structure of our knowledge is part of the structure of the theory. What that means is that the way we know the world is woven into the fabric of the world itself. At the event horizon of a black hole, that stops being just a cool philosophical idea and starts looking like a fundamental law of the universe. So if that's true, where's the line between us, the observers, and the universe we're observing? And can we ever really find it?